An astounding phenomenon has been going on in the solar system closest to our own, one that can raise your eyebrows instantly. The planet Proxima b, one of the system's planets, has been sending out some peculiar signals. For your information, Proxima Centauri is only 4 light-years away from Earth. The most brilliant minds in the space community have been puzzled by the unusual anomalies known as artificial lights. But what exactly are they? Does this suggest that there is intelligent life on the planet? Perhaps we're not alone. Do we have a big civilization? It's absolutely a possibility. BLC-1, our nearest neighbor star, was the source of a signal detected in late 2020. The signal is currently being analyzed to make sure it isn't merely an echo of our civilization, which is generally what these signals turn out to be. So, why not just look straight at the planets in Proxima Centauri to discover if there is civilization there? The radiance from our planet's night side is the most obvious indicator that someone lives here from space. Light from our cities is emitted into space. The issue is that today's generation of telescopes lacks the power to detect lights in other solar systems. However, several scientists are already evaluating the capabilities of previously conceptualized future-generation telescopes. That's accurate. The James Webb telescope is in our sights. What conclusions were drawn from it? Yes, if we were sufficiently developed or glowing, we would be able to determine if Proxima Centauri is home to another civilization. Recent research on Proxima Centauri B's potential to detect these artificial lights addresses the likelihood of techno-signatures at Alpha Centauri. We may hope to learn a lot more about this planet when new equipment, particularly the James Webb Space Telescope, is developed. According to what we know now, the planet is in the habitable zone and has a mass equivalent to that of Earth. It also circles the closest star. The most recent research also mentions LUVOIR, the Large UV Optical IR Surveyor, a multi-wavelength space-based observatory that might launch as early as 2035. To maintain a technological society on a tidally locked planet with a perpetual night side, authors Lisa Taber of Stanford University and AVI Lab of Harvard note that artificial illumination would be required. This is one of the longest shots since it is extremely unlikely that civilizations growing around nearby stars will collide. On the flip side, a civilization emerging somewhere else can be identified by the artifacts it has left behind in the worlds it has chosen to explore using JWST's camera. There are a few techniques to identify the presence of extraterrestrial technology in another world. For instance, with a vast constellation of satellites, we could be able to see how the light of a far-off world wanes. With the growing number of satellites that we launch into orbit, the same things happening on Earth could also be occurring there. A nuclear battle may leave a trace in the atmosphere. Does it sound familiar? Even while these technological signs may be the result of a comet collision or orbital debris, artificial lighting is different from starlight. Researchers Eliza Taber and AVI Lab conducted a virtual alien light search on the Webb last year, but the findings were a little shoddy because it isn't yet entirely functioning. The Proxima b planet, which is the only Proxima Centauri verified planet and is 4.25 light-years from Earth, is the target of the virtual JWST. A rocky planet called Proxima b is located in the habitable region of the M-class red dwarf star Proxima Centauri, which has just 12% of the mass of the Sun. At around 1.6 Earth masses and 1.3 times our radius, Proxima b is heavier than us. It travels just 5% of the distance that Earth orbits the Sun, 7 million kilometers, in just 11.2 days as it orbits Proxima Centauri. As a portion of the solar illumination that our planet's day side reflects, Taber and Lab scaled up artificial illumination. On this scale, 0% implies that the planet's night side is entirely dark. 100% would imply that the planet's night side and day side are both equally bright, which is likewise not conceivable. It is considered that the putative civilization on Proxima b uses a sort of light akin to Earth-based LEDs, which are artificial. Then what have we learned thus far? The Webb could identify the artificial light with an accuracy of 85% if Proxima b's artificial night side illumination exceeds 5% of the natural day side illumination. Webb's detection rate would increase to 95% if artificial light reached 9%. Now I realize that 5% light doesn't seem like much to you, and you're probably correct. Since our Sun is around 20 times brighter than Proxima Centauri, the light from a star is just as feeble when compared to it. It's similar to setting a firefly close to stadium lights. However, even so, such light is substantial on a cosmic scale. In contrast, just 0.001% of the reflected stellar illumination is represented by artificial lighting on Earth. In other words, the Webb would not be able to detect a civilization on Proxima b that is as lit up as ours. Those lights would need to be 500 times brighter. That situation is conceivable. As we have previously indicated, Proxima b's orbit is so close to that of its host star that it may be tidally locked, with one side of the planet constantly facing the star and the other experiencing eternal night. A tidally locked planet civilization will likely need to concentrate on improving its lighting system and might utilize extremely powerful orbital mirrors to reflect sunlight onto the planet's night side, which our telescopes could view. But, of course, that's only a theory. Modern technologies of LUVOIR and HABEX could advance this discovery. According to studies by Taber and Loeb, additional telescopes in the future, like LUVOIR or the Large UV Optical Infrared Surveyor, may be even better at seeing the glimmer of an extraterrestrial civilization than JWST. Thomas Beatty from the University of Tucson's Department of Astronomy published his findings just a few days later, looking at how these telescopes would be able to detect city lights on planets circling stars out to a distance of 30 parsecs, or PC, as well as on Proxima b. Look at both LUVOIR and HABEX, or the Habitable Exoplanet Observatory. About 3.26 light-years separate 1 PC. Exoplanet cataloging and direct imaging missions by LUVOIR and HABEX are both set to launch in 2035. There is still more work to be done before that. Beatty employed computerized replicas of the LUVOIR and HABEX observatories on several star systems that contain both potential Earth-like planets circling G, K, and M-class stars, as well as known planets like Proxima b. Researchers also calculated the proportion of the planet's surface that was populated by cities. The night side of planets gets brighter the more urbanized the place is. The sort of artificial lighting used in this model mimics high-pressure sodium streetlights, which are the most prevalent lights on Earth. It also has a spectrum that can be distinguished from that of starlight. Therefore, the variables are the planet's distance from Earth, its level of urbanization, and the type of star it orbits. In every case, for at least 100 hours, the virtual scopes have been viewing planets to gather enough light coming through the instrument to discern the target. Only 0.05% of the surface of the Earth is urbanized. According to our telescopes, they wouldn't be able to see us if they were coming from Proxima Centauri. If urbanization were to reach, say, 100%, it could be possible to view a far-off society more clearly. But what does 100% urbanization actually mean? That is referred to as an ecumenopolis. An ecumenopolis is a city-planet, a place where a single enormous city spans the whole surface. It has a real science fiction sound. The greatest thing is that there are already several instances, such as Coruscant, the capital of either the Republic or Empire in Star Wars, or the ecumenopolis planet type in the Stellaris space strategy games. However, it's more likely than not that a highly developed society might enclose both their globe and an endless metropolitan landscape. How obvious would that world be then? According to a model of the findings, future observatories would be able to find the ecumenopolis world around 82 stars close to the Sun. It takes up a lot of room. This implies that if someone is blazing that brightly somewhere, we might be able to see them within the next 10 years. Let's cross our fingers for that one. A spaceship's beacon? But we're not finished yet. Proxima b is presently the main goal since research shows that nearby red dwarf stars offer the highest possibility for finding urban worlds. Using next-generation telescopes, it would be simple to fight an ecumenopolis on Proxima b. Only 5% of the planet's surface was found to be populated, yet it is still 10 times greater than the rate of urbanization on Earth today. But here's the deal, within the next 100 years, Earth will have grown by only 0.5%, according to current city growth rates, which is a blink in cosmic terms. If there is an extraterrestrial society, it may already be at this stage of urbanization if they have a long lifespan. Therefore, we cannot say with certainty that technological civilizations are long-lasting. One of the motivations for SETI, or the hunt for extraterrestrial intelligence, is that there is greater optimism that we can continue to keep the lights on when another person is shining in the void. Who knows, those lights may represent a cry for assistance from an extraterrestrial race. We will discover this sooner or later, however, we'll keep an eye out. So, after all, what, according to you, is the energy of those lights on Proxima b? How soon do you believe the Internet and other upcoming telescopes will produce proof? Share your thoughts in the comments section below. Thank you for watching our video, and see you soon in our next.